In the last 3,000 years, the Earth's magnetic field has weakened by about 30%, and the process continues. But what if this is just the beginning of something much bigger? This invisible protector protects us every day, but what happens if it starts to malfunction? Let's look at how the magnetic field works, what's happening now, and how it could affect our lives. The Earth's magnetic field is the first line of defense of our planet, an invisible shield that extends far into space. Without it, the Earth would look like Mars, a barren desert devoid of atmosphere due to the solar wind. Mars' atmosphere today is extremely thin and consists mostly of carbon dioxide, making it unable to retain heat or protect the surface from radiation. On Earth, on the other hand, thanks to a magnetic field, the atmosphere remains dense and rich in oxygen and nitrogen, providing a viable environment. But what is this shield and how does it work? The Earth is like a huge rod magnet. The source of its magnetic field is a giant ocean of liquid iron deep beneath our surface. This molten ocean, some 1,800 miles deep, creates electric currents hundreds of miles wide and traveling at thousands of miles per hour. Scientists call this process geodynamo, a natural energy plant. When the liquid metal rotates with the Earth, it generates a magnetic field, creating a bubble around the planet, the magnetosphere. But it's not perfect. Its shape resembles a kite. The solar wind, a stream of charged particles from the sun, compresses it on one side and stretches it into a long tail on the other. Van Allen radiation belts. The Earth's magnetic field forms two huge rings, the Van Allen radiation belts. These zones capture dangerous radiation from space like a giant particle gas pedal, protecting us from cosmic rays and solar radiation. But the shield isn't as stable as we once thought. What's happening to the magnetic field now? In recent decades, scientists have noticed that Earth's magnetic field is weakening faster than expected. For example, there is a huge anomaly over the South Atlantic Ocean called the South Atlantic Anomaly. Here, the magnetic field is weakened so much that satellites flying through the area often encounter electronic glitches. But that's not the only oddity. The Earth's magnetic poles are also on the move. The North Magnetic Pole is rapidly shifting towards Siberia at a rate of about 34 miles per year, which is 3 times faster than in the 1990s. Scientists attribute these processes to the internal flow of liquid iron in the Earth's core. Pole reversal. What does it mean? Studies of ancient rocks show that the Earth's magnetic poles have completely changed places hundreds of times in its history. This data helps scientists better understand the dynamic processes at the Earth's core, such as the movement of liquid iron, which creates the magnetic field, and the reasons for its periodic changes. The last such reversal occurred about 700,000 years ago. The reversal does not happen instantaneously. It is a slow process that can take several hundred to several thousand years. During this time, the magnetic field becomes complex, with additional magnetic poles appearing in unexpected places. Although a complete disappearance of the magnetic field is unlikely, its weakening could have serious consequences for technology and navigation. The South Atlantic Anomaly, a problem for satellites. The South Atlantic Anomaly is a weak spot in Earth's magnetic defenses, and it's already causing problems. Scientists first noticed this anomaly in the 1950s, studying the magnetic field using ground-based measurements. Today, it is actively studied by satellites such as the SWARM mission, which can map changes in the magnetic field in detail and analyze their effects on satellites and radiation. Satellites passing through this zone are forced to turn off sensitive electronics or increase radiation shielding. If the weakening of the magnetic field continues, such failures could become more frequent and serious. Radiation and life on Earth. One of the biggest concerns is the issue of radiation. However, our atmosphere remains our main protector, blocking most of the harmful radiation. It is so effective that its protective properties can be compared to a 13-foot concrete wall. However, some animals may find it difficult. For example, sea turtles, whales, and birds that use the magnetic field for navigation will have to adapt to the changes. But these processes are so slow that species will have time to adapt. Impact on technology and training. If the magnetic field continues to weaken, technology will become more vulnerable. Power companies are already taking steps to protect grids from geomagnetic storms, and space agencies are developing better shields for satellites and spacecraft. We live in a unique time. Today, we have a unique opportunity to observe these changes in real time. Data collected by satellites is used to predict geomagnetic storms that can affect power grids and satellite communications. For example, scientists analyze changes in the magnetosphere to predict possible disruptions to GPS and satellite internet service and minimize the effects on aviation and maritime navigation. Satellites such as the European Space Agency's SWARM mission monitor the state of the magnetic field on a daily basis. This gives us a chance not only to study these processes, but also to prepare for possible consequences. The Earth's magnetic field is indeed changing, but that's no reason to panic. Scientists are already developing new technologies, such as improved protection systems for satellites and spacecraft that are resistant to radiation. Specialized sensors are also being created to monitor the magnetic field in real time, allowing for advance warning of dangerous geomagnetic storms. In addition, power companies are testing adaptive systems to protect electrical grids from overloads caused by magnetic anomalies. This is a natural process that our planet has gone through many times before. What is unique about the current situation is humanity's ability to learn, understand, and adapt to these changes. Perhaps our time will be the starting point for a new stage of understanding the planet and its interaction with the cosmos.